electrochemical series of elements tells us about whether a species is better oxidizing agent or a better reducing agent. We can predict which metal can act as a cathode and which metal can act as an anode in an electrochemical cell. So let us have a look on this series. We have electrode potential values calculated for different elements depending on their tendency to gain electron or lose electron. We have a list of electrode potential values. Electrode potential is basically a reduction potential value. So, an element which has a tendency to get reduced or gain electron will have higher reduction potential in comparison to an element which has tendency lesser in comparison to other elements. For example, if we have fluorine, fluorine is a non-metal, so it has a tendency to gain electron. So reduction potential of fluorine is high. So electrode potential for fluorine is highly positive, whereas metals such as lithium, sodium, magnesium, zinc, they have a tendency to lose electron. So they want to get oxidized. They do not want to get reduced, right? So they do not have a tendency to get reduced. So their reduction potential value is very less. In fact, reduction potential or standard electrode potential is zero eh, for hydrogen and negative for metals. That means metals do not like to gain electron. They want to give away electrons. So they want to metals want to get oxidized. So electrode potential values for metals are in negative, for non-metals are in positive. For hydrogen, electrode potential value or reduction potential value is zero. Alright. So we have a sequence on the basis of values of electrode potential. So higher the electrode potential or reduction potential, better is the oxidizing agent. All non-metals, fluorine, chlorine, bromine, these are good oxidizing agents. And metals such as lithium, magnesium, zinc, they are having negative electrode potential values or reduction potential values. So they are not good oxidizing agent. In fact, they are good reducing agents. So metals are good reducing agents and non-metals are good oxidizing agents. So if we start from non-metals and move towards metals, non-metal, then hydrogen is in between and metals are at the bottom. So higher electrode potential for non-metals, they are good oxidizing agents. And when from non-metals you move towards metals, then electrode potential value from positive to goes to zero for hydrogen and goes negative for metals. So best oxidizing agent is fluorine and best reducing agent is lithium, which is placed at the bottom. Maximum electrode potential value, minimum electrode potential value. Fluorine has maximum electrode potential value. It is best oxidizing agent. Lithium has minimum electrode potential value in negative. So it is best reducing agent. Best oxidizing agent fluorine, best reducing agent lithium, and hydrogen is in between, right? So from the value of electrode potentials, we can figure out which is a better oxidizing agent, which is a poor oxidizing agent. So from if we move from fluorine towards lithium, you can see for fluorine electrode potential value is plus 2.87. That means fluorine is a very good best oxidizing agent, I can say best oxidizing agent. And here lithium is best reducing agent. So we can easily say when we move from top to bottom from fluorine to lithium, then oxidizing agent character decreases and reducing agent character increases. So fluorine is best oxidizing agent and lithium is best reducing agent. When you go downwards, reducing agent character increases. When you go upwards, oxidizing agent character increases. All right. So if you have a combination for let's say copper and zinc. You can check out the values. For copper, it is 0.34. For zinc, you will have minus 0.44. So, out of copper and zinc, if you take a copper electrode and zinc electrode, you can figure out that copper has a tendency to gain electron because its reduction potential is more. So, it wants to get reduced, gets converted into copper. Whereas zinc has lesser reduction potential, so it wants to lose electrons. So, zinc will have oxidation and copper will show reduction. So, you can have a cathode for as copper in an electrochemical cell, and you will take anode as zinc. So, the material which has higher electrode potential will become cathode, and the material which has lower reduction potential will have become anode. Alright, you can figure out these things also, and more importantly you can figure out which is more electronegative, which is more electropositive, which is less electronegative, less electropositive from these values. More electrode potential, more is electronegativity. Less electrode potential, less is electronegativity, and more will be electropositive character. So the element which has higher electrode potential is electronegative element. Element which has lesser electrode potential is electropositive element. So we have categorized elements on the basis of electrode potential values, where you can see that we can predict whether an element is electropositive or electronegative on the basis of electrode potential values. And we have a sequence that has been mentioned over here and here, that all halogens have higher electrode potentials, so they are best reducing agents, whereas metals are poor reduce. Best oxidizing agents are non-metals. These are best oxidizing agents, whereas metals are best reducing agents. Now, if we figure out that which one will liberate hydrogen from a mineral acid, all right. So that has also been given over here, that if you have an element which has a reduction potential higher than hydrogen, let's say copper. So copper will get reduced and hydrogen will get oxidized. Whereas if you have an element below hydrogen, that means negative electrode potential values, then hydrogen will be liberated from the mineral acid. If you take HCl and have a reaction with zinc, then what you will have? Zinc will get oxidized. Zinc plus HCl will give you ZnCl2 plus hydrogen gas, because in zinc zinc has negative electrode potential and hydrogen has zero electrode potential. So hydrogen has a tendency to gain electron as compared to zinc. So it will gain electrons, 2 electrons, and it will liberate as hydrogen gas, whereas zinc has lesser electrode potential. So what it will do, it will get oxidized into Zn plus 2, leaving out 2 electrons. So when you have a reaction between zinc and HCl, then what happens is you take 2 HCl and we get zinc chloride plus hydrogen gas. So Zn converts from 0 oxidation state to plus 2, whereas hydrogen from plus 1 goes to 0 oxidation state. So hydrogen is getting reduced, reduction is happening for hydrogen, whereas for zinc oxidation is happening. So from this we can make out easily that if an element, if a metal has electrode potential less than hydrogen, it can liberate hydrogen from mineral acid. Whereas if a metal has greater electrode potential than hydrogen, then it cannot liberate hydrogen from mineral acids. And we can have a classification like more electropositive, less electropositive, more electronegative, less electronegative on the basis of electrode potential. If you have a greater, if a element has a greater electrode potential values, it is more electronegative, less electropositive. If element has less electrode potential values, it is more electronegative. No, it is less electronegative and more electropositive. So if I give you a trick, you can have it like this: electropositive character is inversely proportional to electrode potential. Electrode potential, right? So less is electrode potential, more will be electropositive character, and electronegative character is in electronegative character is directly proportional to electrode potential. More is electrode potential, more will be electronegative character. For example, fluorine has the highest electrode potential, so fluorine is the most electronegative element. Here lithium has the minimum electrode potential, so lithium is electropositive element, not electronegative. This is electronegative, most electronegative. This is most electropositive on the basis of electrode potential values. So this is it for now. Thank you so much.